Okay, so that was up to question 20. We're going to start question 21 now. So this one's asking us to calculate the volume of 2 molar, the volume of 2.0 moles per litre HCl to dissolve 5.4 grams of aluminium. Now, the important thing here is to realize there's actually quite a few steps in this process. We're given an equation, and this equation here is balanced. You can work that out by counting up the number of each atom on the left and right. We need to look at the reactant side, and we can see that two moles of aluminium react with 6 moles of HCl to make our products. So if we have 2 of aluminium and 6 of our HCl, that's giving us a ratio of 1 to 3. So for every 1 aluminium, we have 3 HCl's. That also means that for every 1 mole of aluminium needs 3 moles of HCl to react with. Now, if we want to work out how much HCl, we need to work out first how many moles of aluminium. We cannot compare grams, so we can't just use this number here, grams. We have to convert it into number of moles first before we can do anything. So the number of moles of aluminium is the mass of aluminium divided by the molar mass of aluminium, in this case 5.4 grams, divided by the molar mass of aluminium, which is, looking at the periodic table, 26.982 grams per mole. Oops, that's meant to be a -1. So I'll just throw it in the calculator. We have 5.4 divided by 26.982, and we end up with 0.20 moles. Now, this is how many moles of aluminium we have. And using the ratio of 1 to 3 for our aluminium to HCl, that means we need to times this by 3 to get the number of moles of HCl. So that will be 0.60 moles. So 0.2 moles of aluminium needs 0.6 moles of HCl. 0.2 moles of aluminium needs 0.6 moles of HCl. And we can't just chuck that in, with spoons, because we actually have a solution. So our hydrochloric acid comes in a solution in water, 2 moles in every litre. So if our concentration of HCl is equal to 2.0 moles per litre, that means in 1 litre of this solution, there is 2 moles. We need 0.6. So if you remember, number of moles is equal to the concentration times the volume, and we are looking for the volume. That's what we're trying to calculate, this one here. So I'm going to rearrange this first to get volume by itself, and that will give us V equals N on C. So in this case, our number of moles is 0.60. Our concentration is 2.0 moles per litre. The moles will cancel each other out. The per litre on the bottom here becomes litre on the top. And we end up with 0.6 divided by 2, which is 0.30 litres. So that we've done a few steps here, but our final answer is 0.3 litres of this 2.0 moles per litre solution of hydrochloric acid is required to dissolve 5.4 grams of aluminium, which is 0.2 moles of aluminium. Hopefully that makes sense. Now, if we have reacted, so if the number of moles of aluminium that will react is 0.20 moles, this next question is asking us, what is the mass of hydrogen that would come off of that? Oops, that's not working. There we are. What is the mass of hydrogen that would be evolved? Evolve just means to come out of the mixture. we need to know what the ratio between aluminium and hydrogen is. Now, as we can see from the reaction here, the reaction equation, the chemical equation, for every 2 of these, we get 3 H2s. So, however many number of moles of aluminium we have, we're going to end up with a greater number. 1.5 times greater number of H2. So that means 0.2 of these is going to be equal to 0.3, which is 1.5 times. If you wanted to do this more generally, you would have 3 on 2 times the number of moles of aluminium in this case, which is 3 on 2 times 0.2, which is equal to 0.3. So, So 3 on 2 times the number of moles of aluminium is the number of moles of hydrogen. So that's our number there, 0.3. Technically, it should be 0.30. So just to be a little bit more correct, let's put that there. So we know the number of moles of substances is the mass divided by the molar mass. Now we have the number of moles. We can find the molar mass, and the mass is what we're actually looking for in this question. So I'll rearrange this to get mass is the number of moles times by the molar mass, which is equal to 0.30 moles times by our molar mass of H2, which is just 2 grams per mole. That should be moles to the minus 1. And that gives us 0.60 grams. So I times 0.30 by 2 to give us 0.6 grams. So that's how many grams of H2 we get coming out. And there we go. Okay, so our next question, 22. We're getting close to the end. They're asking us the concentration of glucose in the blood of a person. They're telling us the concentration of glucose in the blood of a person was determined by analysis to be 4.5 times 10 to the minus 3 moles per liter, and they want us to convert this into different values. So if we know we have moles per liter, which is, if we scroll up, this will be over here, and we need to get across to here, and I believe to ppm as well, if I read the question properly. So times by molar mass first, and then times by 1,000 to get to ppm. So let's go back down here. So the first one is grams per liter. So we know that the mass concentration is the molar concentration times by the molar mass, which is equal to 4.5 times 10 to the minus 3 moles per liter, times by the molar mass of C6H12O6. Now we can work this out by just timesing the molar mass of carbon by 6, the molar mass of hydrogen by 12, and the molar mass of oxygen by 6. But I am just going to Google it so that it doesn't take as long. Molar mass of glucose is 180.16 grams per mole. So I do encourage you to work it out though. So if we do this, we have 4.5. Actually, let's go 0.005. We end up with 0.81 grams per liter. So, assuming this is correct, we have our mass concentration in grams per liter, and we know that our ppm concentration is equal to our mass concentration times by 1,000, or times by 10 to the power 3, which means this is 0.81 times by 1,000, which moves the decimal point 3 spots, which gives us about 110 ppm. Cool. And that should pretty much be it. Now the 5 marks here comes from maybe a couple of marks from here, and our 3 marks up here would involve calculating our molar mass correctly, as well as getting our correct answer. So we've got this bit here, that bit there, this bit here, this bit, and then this bit. 1, 2, 3, 4, 5. So that was pretty easy. The last bit is question 23, and it says the label of spring water states that the water contains magnesium at a concentration of 4 milligrams per litre, and it's asking us to convert this concentration into other values. So 4 milligrams per litre, if we go up to here, milligrams per litre is the same as ppm, and it wants us to work out our answer in ppb and percentage weight to volume. So ppm to ppb is easy, we just times by 10 to the power 3. But if we want to get to percentage weight to volume, we have to do 2 steps, which is divide by 1,000 and then divide by 10. So we'll try and keep that in mind. So getting down to here, we have percentage weight to volume. Our ppm needs to be divided by 1,000 to get to our grams per litre, and then to get from there to, actually, I'll draw it a slightly different way. We have our ppm needs to be divided by 1,000 to get to grams per litre, and then it needs to be divided by another 10 to get to percentage weight to volume. So we take our 4 ppm, which is 4 milligrams per litre, we divide by 1,000, giving us 4 times 10 to the negative 3 grams per litre. And then we divide it by 10 again to give us 4 times 10 to the negative 4 percent weight to volume. And that's our answer. Now, if you remember, to get from ppm, which is our original value here, which is equivalent to ppm, so ppm to ppb is, not dividing, timesing by 1,000. So all we need to do here is go our 4 ppm is equivalent to 4,000 ppb, or 4 times 10 to the power 3 ppb. Now, I would say this is probably a little bit easier than the previous one, but there's even more marks according to them. Awesome. So we're going to go through dilution in our next lesson. We're not going to go over these questions, but I'll explain all this stuff that you see down here, which is our n equals c times v and a whole bunch of them mixed up. Cool. Hopefully this helped out, and if you were stuck, my explanations helped enough to help your understanding.